So for today's video, we look into topic 6, periodic table. And in this topic, we have two subtopics. We have 6.1, classification of element, and also 6.2, periodicity. And for today's video, we are focused into 6.1, classification of element. In this subtopic, we have two learning outcomes. The first one, we are going to identify and also understand the position of period, groups, and block in the periodic table. Other than that, we will also predict or deduce the position of an element in the periodic table by using electronic configuration. We have learned electronic configuration in your topic 5, and we have two types of electronic configuration. We have our SPDF notation, and also we have our orbital diagram. And make sure you have understand and have the ability to write a correct electronic configuration before you proceed to your topic 6. So let's start. A periodic table is actually a table that contains all the non-chemical elements that will be arranged in the order of number of proton or atomic number. So let's see how the arrangements go. Hydrogen having proton number 1, and then you move on to your helium, proton number 2. And then you move on to your lithium, proton number 3, your beryllium, proton number 4, boron, proton number 6, carbon, nitrogen, oxygen, fluorine, neon, and so on. You have your sodium 11, you have your magnesium 12, you move all the way to your aluminium 13, silicon 14, 15 phosphorus, 16 sulphur, 17 chlorine, 18 argon, and so on. You can see the flow of the number of proton is increasing in the periodic table. So everything in the periodic table is actually arranged according to the increasing number of proton. Other than that, periodic table also can be classified into blocks. We have 3 blocks that we are going to learn, and then we can identify the groups. We have 18 groups, group 1 until group 18, and then we have periods, where we have period 1 until period 7. We'll look into each and every one of them. What is meant by block, group, and period, and how can we identify the position or the block, group, and period of a certain element. So let's start with block. The first block that we are going to look into is your S block. That is your S block. Your S block is actually your group 1 and also your group 2 element. So your group 1 and group 2 element will be located in the S block. Next, we have your group 13 all the way to your group 18. Your group 13 all the way to your group 18 is what we call P block. Last but not least, we have our D block. This is your D block, where your D block is your group 3 all the way to your group 12. So we have 3 blocks: S block, P block, D block. Okay, your S block is your group 1, group 2. Your P block is your group 13 until 18. Your D block is your group 3 until group 12. But how do we know the block of an element by using electronic configuration? Simple. When you write the electronic configuration, the electron go into the last orbital. The last electron that go into that particular orbital will be the block of your element. For example, we use a very simple example, carbon. Carbon having 6 proton. So when you write the electronic configuration, you will have 1s2, 2s2, 2p4. And you can see that the last electron goes into the p orbital. Therefore, carbon will be in the p block. So let's check. Carbon is over here. And you can see your carbon is in the p block. Simple. Alright, let's do more example. I have sodium 11. So first and foremost, we are going to write the electronic configuration of sodium first. Start off with 1s2, 2s2, 2p6, 3s1. So the last electron go into your s orbital. Therefore, sodium is in s block. Simple. Alright? Sodium will be in the s block because the last electron go into the s orbital. Next, I have sulphur 16. Start off the electronic configuration with 1s2, 2s2, 2p6, 3s2, 3p4. And you can see that the last electron goes into the p orbital. So where do you think the sulphur located? Sulphur will be in the p block because the last electron that we put in is in the p orbital. Very, very simple. The last example, vanadium 23. So you have your vanadium 23, where we start off with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. And from there, you can see that the last electron is in the d orbital. Therefore, vanadium will be in the d block because the last electron that you put in is in the d orbital. Simple. Alright, and that's it about block. And now we move on to your group. What is actually group? Okay, when we say group, we always say going down a group. When we say going down a group, means it will be going from the top to the bottom. And the group 1 is this. So your group 1 means that you are going from the top to the bottom for this first column. For the second, you have your group 2. For the third, you have your group 3. And then you have your group 4. And then all the way, you will have your group 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then you will have your group 16. You will have your group 17. And we know that in a periodic table, we will have a total of 18 groups. So last but not least, your group 18. So this is all your group, alright, going down the column. Going down a group, you have your group 1 until all the way to your group 18. And we have a similarity for all the elements located in the same group. For all the elements in the same group, they will have the same number of valence electron. Means that everyone for your group 1, all the elements in your group 1 will have 1 valence electron. And everything in the group 2, everything down the group 2 will have 2 valence electron. Everything in the group 3 will have 3 valence electron. And so on. You have your 4 valence electron, 5 valence electron, and so on. All the way to your group 11, you have 11 valence electron. Group 12, you have 12 valence electron. But when you reach group 13, your group 13 will go back to your 3 valence electron. Group 14, 4 valence electron. And your group 15, you will have your 5 valence electron. Group 16, 6 valence electron. 7 valence electron for your group 17. Last but not least, 8 valence electron for your group 18. So why is this happening? How do I know the number of valence electron that I have when I'm having a set of electronic configuration? Simple. A bit of tips for you over here is for the group 1 and group 2, this is your group 1 and group 2, alright, your S block, where you have your group 1 and your group 2. The number of valence electron will be the group number. So group 1, group 2 means that group 1 will have 1 valence electron, group 2 will have 2 valence electron. And then for your P block, where your P block is your group 13 until your group 18, all the way from your group 13 until your group 18, your P block, the number of group will equals to the number of valence electron plus 10. So for example, your group 13, you have 3 valence electron plus 10. So you have group 13. For example, your group 18, you have 8 valence electron plus 10. So you have your group 18. Alright, see that case? So for your P block, the number of group will equals to the number of valence electron plus 10. Last but not least, when you have your group 3 all the way to your group 12, which is your D block. That is your D block, where you have or you are moving from group 3 all the way to group 12. And for this block, the number of group will again equals to the number of electron. Means that in your group 3, you will have 3 valence electron. In your group 12, you will have 12 valence electron. You only plus 10 for the P block element. You only plus 10 for the P block element. Okay? Next, how can I know the number of valence electron when I'm having a set of electronic configuration? Very simple. If I'm having a set of SPDF notation, and the last electron that goes into the s orbital, the valence electron will be the total electron in the s orbital. For example, I have sodium 11. If I'm having sodium 11, my electronic configuration will be 1s2, 2s2, 2p6, 3s1. And my last electron goes into the s orbital. Therefore, the valence electron of sodium will be the electron in this s orbital. So, number of valence electron will be 1. Next, if the last electron that you fill in is in the p orbital, what would be the valence electron? The valence electron would be the electron in the s orbital and the p orbital of the energy level, of the last energy level. So for example, if I'm having fluorine 9, my SPDF notation will be 1s2, 2s2, 2p5. So my last electron is located in the p orbital. And my number of valence electron will be plus the s orbital and the p orbital of the higher energy level. Alright, so we are not taking the 1, we only take the 2s2 and 2p5. So number of valence electron is 7. Okay, so if the last electron that you put in is in the p orbital, we will be taking the electron in the highest s and the highest p. We plus them, and that will be your number of valence electron. Last but not least, if the last electron that you put in is in the d orbital, the valence electron will be those in the 4s and 3d. For example, I have vanadium 23. So for vanadium 23, my SPDF notation will be something like this. And as you can see, the last electron goes into the d orbital. The valence electron will be those in the 4s and 3d. 4s and 3d. So in the 4s, I have 2 electron. In the 3d, I have 3 electron. In the other words, vanadium will be having 5 valence electron. Okay, simple. So conclusion of it, when the last electron that you put in is in the s orbital, the valence electron will be the one in the s orbital only. If the last electron that you put in is in the p orbital, the valence electron will be in the s and p orbital of the higher energy level. If the last electron that you put in is in the d orbital, the valence electron will be those in the 4s plus 3d. 4s plus 3d. That will be the valence electron. Okay? So let's do some example. Potassium 19. The electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. That is your 19. Before anything, we identify the block first. And how do we identify the block? The last electron that fell into which orbital? The last electron fell into the s orbital. Therefore, potassium is in S block. And what would be the group? For the group, we need to identify the valence electron. So we need to find out the number of valence electron. How many valence electron potassium having? Look at the last electron that you put in. The last electron is in the s orbital. When the last electron is in the s orbital, number of valence electron will be only the electron in the s orbital. Therefore, in the s orbital, I only have 1. So, the number of valence electron will be 1. Since it's a s block and the number of valence electron is 1, therefore, potassium will be in group 1. Why group 1? Because in s block, number of valence electron will be equals to number of group. Bear that in mind. In the s block, the number of valence electron will be equals to the group. Simple. Next, I have bromine 35. Electronic configuration of bromine 35 will be 1s2, 2s2, 2p6. You should be extremely good in writing electronic configuration at this moment. Okay, so that is your 35. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. So the last electron is located in the 4p5. Therefore, bromine is in the p block of the periodic table. And what would be the number of valence electron? How can we identify the number of valence electron for the p block? We'll be taking the electron in the ns plus the np. So the np, the last np that we are taking is 4p5. So the ns will be 4s2. Alright, so the number of electron will be the electron in the ns plus the np. The np is 4p5. So we are taking the highest energy level. Highest energy level is 4 over here. So 4s2 plus 4p5. Number of valence electron is 7. Okay, and what would be the group? For p block, we know that for p block, number of group will be equals to number of valence electron plus 10. So the number of group will be the number of valence electrons 7 plus 10. So your bromine will be a group 17. Is that clear? Simple. Last but not least, one more example. Titanium 22. Electronic configuration of titanium 22. 1s2, 2s2, 2p6. You can definitely write that better than I do. And we stop at 3d2. Alright, of your titanium 22. And the last electron that you put in right now is in the d orbital. Therefore, titanium is in the d block of the periodic table. Titanium will be located in the d block of the periodic table. If you don't trust me, open up your periodic table and check that. You will find your titanium in the D block. And next, we are going to work out the number of valence electron. So the number of valence electron over here will be the 4s plus the 3d. And over here, our 4s is a 4s2, our 3d is a 3d2. So I have 2 electron in the 4s, I have 2 electron in the 3d. So the number of valence electron is 4. And for the D block, the number of group will equal straight away to the number of valence electron like in your S block. Okay, so the number of valence electron is 4. Therefore, your titanium will be...
Whenever you want to remove an electron, the electron must be removed from the outermost shell, which is the furthest away from the nucleus.
Okay, the valence electron is very important to identify the group, as well as knowing the block. You need to know the block, you need to know the valence electron, then you can know the group. Okay, next we are going into period, and this will be one of the easiest thing in this entire video. So what is actually period? We always say across a period. What do I mean by across a period? Means we'll be cutting from the left to the right. And this is what I call period 1. So in the period 1, you have your hydrogen and helium. Then you have your period 2 after it. Then you have your period 3 all the way down. And like I promised, in a periodic table, you will have 7 periods. That is your period 7. And what is the similarity of those elements in the same period? Those elements in the same period will have the same number of shells. For example, for period 1, means your hydrogen and helium will have 1 shell. Alright? When in a period 2, means your lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon will have 2 shells. Okay, you will have 2 energy level. And so on. Period 3 means you are going to have 3 energy level. Period 4 means you are going to have 4 energy level, and so on. And how do I identify the period of an element by using electronic configuration? Very, very simple. The highest number of the shell occupied by the element, the highest n over here, I mean by the highest n. The highest n that the electron occupied will be the period of the element. Alright? For example, over here, if I'm having oxygen 8. Oxygen 8 means 1s2, 2s2, 2p4. And the highest n over here is 2. Means that oxygen will be in period 2. You can see over here, oxygen is in period 2. Okay? Simple. The highest n of your electronic configuration will be the number of period. Simple. Let's do a few more examples before we finish. We start off with calcium 20. Calcium 20, the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And which period calcium located? Simple. Look at the n. I have n equals to 1, n equals to 2, n equals to 3, n equals to 4. So the highest n is 4. Therefore, calcium is in period 4 in the periodic table. Simple. Let's use this example to find out the block and the group as well. Let's try. So, the block over here, what block? It will be S block because the last electron that you put in is in the S orbital. So, this thing will be in S block of the periodic table. What would be the group? What do you think the group will be? So, S block, we know again, S block means the number of group will be equals to the number of valence electron. But the question over here, how much is the valence electron? For the S block, the number of valence electron will be equals to the number of electron in NS. And the last S that we have is 4s2. Therefore, the number of valence electron will be 2 electron. 4s2, so we have 2 electron in the 4s. Therefore, the number of valence electron will be 2 electron. And the group will be equals to the valence electron. Therefore, calcium is in group 2. Group 2, S block, period 4. Okay, simple. Let's try one more. Oxygen 8. Very simple, short and precise. Oxygen 8, you have 1s2, 2s2, 2p4. We have talked about it just now to identify the period. The period will be equals to the highest n. So the highest n over here will be 2. Okay, so oxygen will be in period 2. Block, what would be the block? The last electron that fell into that orbital. The last electron goes into p orbital. So p orbital means oxygen will be in the p block. If the element is in the p block, then the number of valence electron will be the addition of the electron in the s orbital and also in the p orbital. So the last p orbital that I have is 2p4. So the s orbital that we will be taking is the 2s2. So I have 2 electron in the s, I have 4 electron in the p. Therefore, the number of valence electron is 6. And it's a p block. Therefore, number of group will be equals to number of valence electron plus 10. So my valence electron is 6 plus 10. Group 16. Oxygen will be in the group 16, P block, and also in period 2. So you can check your periodic table if you don't trust this. So by using only one thing, by using only your electronic configuration, you can know exact position of an element in the periodic table. By knowing the group, the block, and the period, you will know exactly where your element located in the periodic table, the specific location of oxygen. By using only one thing, the correct electronic configuration. Let's try one more. Last one. Titanium 22. We are still using your titanium 22. So your titanium 22 will have this electronic configuration. 4s2, 3d2. So the period, again, what do you think the period will be? The highest n. And the highest n over here is actually your 4s2. Period is the n highest. Alright? Therefore, your titanium will be located in period 4. Because your highest n over here is 4. Next, let's try block. What do you think the block will be? The block is actually the orbital of the last electron that you put in. So the last electron that you put in is in the 3d2. Therefore, it will be in the d block. Alright, it will be in the d block because last electron you put in is in the d orbital. So right now we have two things. We have your period 4. We have your d block. Okay, by knowing the block, we also can work out the number of valence electron. Since it's a d block, so number of valence electron will then equals to the 4s plus the 3d. So the 4s having 2 electron, 4s2, 3d having 2 electron, 3d2. So the number of valence electron over here is 4. So we have 4 electron as the number of valence electron, and since it's a d block again, the number of group will be equals to the number of valence electron. Okay, so I have 4 valence electron, therefore I will be group 4. Your titanium will be in the group 4, period 4, and also D block. And this is the exact location of your titanium. Okay, simple, only 3 things: group, period, block. And everything is depends on the correct electronic configuration. And a bit of tips over here. To know the position of an element, and I repeat, to know the position of an element, the position that you need to find out is period, group, and block. So again, period is the highest n. Alright, the highest n or the highest energy level. The group will be depends on the valence electron. Okay, the group will be depends on the valence electron, and also the block will be depends on the orbital of the last electron that you fill in. But bear that in mind, the group and the block, they are good friends. Okay, to identify the correct group, you need to know what block they are located in. And if you realize, every time when I write the electronic configuration, to find out the period, group, and block, my electronic configuration must be the neutral atom or element electronic configuration. You cannot use the electronic configuration of the cation or anion to find the period, group, or block. To find the period, group, and block of an element, you must use the electronic configuration of the neutral atom. Always the neutral atom. Whenever you want to know the period, group, and block in the periodic table of an element, you must use the electronic configuration of the neutral atom. Always. Okay? And thank you for watching this video. I hope you get it. It's a very simple thing with one condition. Write the correct electronic configuration. And if you like this video, don't forget to press the like button and subscribe to my channel for more videos. Thank you for watching, and I'll see you.